So the issue I have with this is, I hope the issue is that and having to percentages, the way that yes, for we tried to plan it like we were talking about in the back, so now the best case is I couldn't see immediate creating at all. Like I would put it in and I would put it in and set it up correctly. It would work. And I could fit it all. But so this is the way. What's your 18 now?
You can use that one. You can just turn it back. I don't know why that kid left it twisted that way. It's a high school student. He just likes to leave an impression when he goes. Is he got it stuck? I meant to gripe at him before he left. He was busy giving me instructions on how I needed to make him a list or something.
Oh, that's exciting.
So I was just trying to get him on out of here. I love those people who are like, I will do my work as soon as you do a whole bunch of work for you. Yeah, no. Daniel's gonna get tricky. We'll have to turn it all the way to where it's not on the desk.
Yeah, I do. Stupid about this. Like it has something to do that. No, it doesn't hurt stupid. So I'm just doing
Thank you, sir. I try not to get grossy with people. Okay. Yeah, the IT staff definitely has installed these with that idea in mind. Those people are supposed to be different. Look at all of you.
Okay, so when you have to start the section over here, otherwise you just start. Usually what I do is I do open folder, open up my library, and start to file what I want. Well, I mean, whatever I do, it knocks me into that folder, but it only pulls up my folder. Well, in practice, I would go to the actual library. I had that file. Oh, open with yeah, open with it. That's how I do it. Because there's a way that there's a way that open the link file if you want. Wait a second. How do you end a comment? Well, I just have to pull it out. So I was trying to pull it up something back. Hopefully. I have so it's forward slash asterisk.
Last time when we left, we were exploring how much I hate working with two-dimensional arrays, right? And another student in the other class had solved this, so I'm just going to show you his solution for you to put into your colab document. Now, he did it in a way different way than I was approaching. So this is our Chapter 7 collab, Activity 10, where we were working on the two-dimensional array. And when you get to it, you should see, we started on it last time, and we ran into errors, and I was like, two-dimensional arrays are dumb anyways. So here's some good code. And again, two-dimensional arrays, dumb. We have better ways of doing it. So here's some code for you to put into your collab document. So this again is example 7.11. This is the one we're looking at here. I better put this in mine too, huh? Okay, how you doing? I know that's some ugly code, isn't it? We start getting when we're putting square brackets and all sorts of things into stuff, it can get pretty ugly. I'd like to run this in Colab first, but then I'd like to run it under that Visualize website so we can kind of try to visualize what's going on here because it's some pretty interesting code. Before we run it, though, one thing that I want to point out to you is that Justin, the student who developed this solution, found this formatting option for Python. I know as we've been working through the semester, working on different ways we could format our output, we've seen that there's a lot of different ways that we can do it in Python for sure. Well, Justin found another way. This is called an F string, based the way as he's referring to it. And this F here before the string is telling Python, format this string. And by using that F string, then we're able to put our variable names within curly braces where we want that variable to show up in that output. So instead of us having to use the %D thing as a placeholder, this becomes the placeholder and is replaced by the actual variable that's named within the curly braces. So it's a really cool way to do it. It's, I think, a new Python feature. This is a lot very similar to a way that you can format string output in C#. So I would say that somebody, because remember, Python is open source, so people can add capabilities to it all the time. So someone that was a C# person probably said, what is with all of this crazy output formatting? And I'm going to do it another way. And so we have yet another way, but it works really good. And I think everybody in the other class felt like this was the most understandable way of the ones that they've seen so far. We kind of all prefer it. So yes, I will continue to torture my classes with all of the different ways because they're going to see them everywhere, just like you guys. But I do think this one is really, really nice. Okay, so what do we have going on in here before we run it? If we step through this code, we're starting out with a for loop with a variable I that we're going to use as our index. And because we've defined scores as a two-dimensional array, we're going to use I as a pointer into the first dimension of that array. So that's going to be our row. It's going to define the row number that we're on. So we're saying for that first row, I want you to insert something. And I'm not exactly sure. As we run this, we might have to do some debugging. We are not committed yet to saying that this is absolutely perfect code, but it is code that we can use as a starting point. So let's try running it. Get it back over here. Oh, I got a typo there. That's my fault. You probably don't have that typo. Okay, so here I'm going to enter scores for student 1, and I'm going to put in 100, and then it's going to crash. Score is not defined. Oh, there it is. I have it named test instead of score. Again, you probably don't have that problem. That was just me. Okay, now it's working, and yours was probably like that all along because that was me doing 7 things at once, none of them well. Okay, so I'm going to put in another score. Oh, and so Justin, when he was testing, he said, I limited this down to 2 scores because he didn't want to type in 5 or 6 scores for each student. So that makes sense. We'll respect that. So it took those 2 scores for student number 1. Now I'm going to put in 2 scores for student number, well, should be student number 2 there. So we see a little bug. But I want to put in different scores so that I can tell that I'm getting things in the right place. You know, sometimes when we're testing, I'll just type that same number over and over if we're doing an average or something like that. In this case, I don't want to do that. So I want to make sure that I'm getting the data where I think it needs to go.
After line 15, you're missing one line that's student plus equals 1.
Oh, okay. So that's going to make me crash, huh?
No, I think that's just why it didn't say student 2.
Oh, you got it. Perfect. So that would be student.
On after line 15.
Right there?
Yeah.
Yeah. Look at him using those Zoom tools. Is that better?
Right here. Plural.
What about it?
Doesn't match. So right.
Right. It's a different variable. He's actually using it to input the score, and then it's getting added to the scores array. So we always have to be careful about those kind of things. That's where I was getting confused on it too.
On line 18, you need test plus equals 1. Or 20 on yours. Sorry.
Do what?
You need test plus equals 1.
Oh, down here in this lower loop?
Yeah.
Okay. Is that good?
Test.
Test? Oh, you're so picky. Okay. It probably would make a difference. Huh? Now that looks better. So we should be seeing I'm not sure where that variable is even being used in this. Oh, okay. Is the student number. So the way this is coming out is good, but it's kind of misinterpreted, right? So what Justin has here, which is so good, is he's ended up with this first array. How can I say this? We should have a grid, right? Rows and columns, and there should all be scores. And we know row 1 matches student 1, or row 0 matches student 0, actually. And instead, what we have here is each row has the student number followed by 2 scores. So that's not exactly what we were looking for, right? What we're looking for are 3 test scores here. And we know just through the magic of us knowing things that each row belongs to a different student. If there's nowhere in there in this array for us to keep track of that student number, we should just have test scores. So we do have a little bit of a problem. Let's see if we can run this in the visualizer to identify that issue. So I'm going to copy this code, turn off our music. I know it's nice that that worked. And I'm going to try to visualize our Python. And I'm not in Chrome here, so it doesn't have my history. All right, there's our Python tutor site. This one should be super interesting. We'll see if we can crash their site. We might be able to. We can do it quite a bit. All right, we're starting out allocating our 2-dimensional array. And there it is. So it's saying that our scores array is comprised of 2 different lists, 2 empty lists. Is kind of what it's visualizing here for us. So that's good. And then I'm gonna go ahead and next a couple of times and let it get our variables allocated. So now I'm in my for loop and I started out with another variable, I. And I'm going to use I as that index number. And the original algorithm that was presented by our pseudocode felt like we should be using student. That variable is our index here. So we've kind of complicated things a little bit by adding in this new variable I. So it is making things a little bit tougher. It's definitely a complicated mess. So I'm going to click next here and let that print statement work. There it goes. It says enter 2 test scores for student 1. I don't know, did I miss the input? No, okay. So the next statement then, line 15, said insert 0, student. Well, our student number was 1. So what that insert statement did is it said at index position 0, insert whatever the value is of this variable. So now we have index position 0 in our array, and it'll have the value of 1. Because that insert statement is a little bit different than the append statement we've used in the past. Now we're going to add to our student counter, and then go into our loop to get grades. So for our first grade, we're going to prompt for input. I'll do the 100. And he's reading that into a temporary variable. Now that he knows that it is an integer, we're going to put it into our scores array. So now he's saying, insert this value using the test variable is the index pointer, which is set to 1, and put in that first score. So I'm going to click next and we'll see how that gets edited in. So there is that first row of our array getting built. I'm going to keep going, adding to our test number, and then typing in another test. We're going to insert that into our array. It's test number 2. So our index went to 2, and we added that value inside that row. Now, we should drop out of this for loop and go back to our outer loop, which is our student loop. Now in our student loop, we're going to prompt to enter 2 scores for this student. Then we're going to create a row for this student in our array. Our student variable is now set to the value of 2, and we want to insert that value of 2 at index position 0 of this new row. So here's our new row. Now we have index position 0 with that student number value of 2. Now we're going to go into our loop to do our scores. We'll add our first score, 80. And then we're going to insert that into our row, and then update our scores number, and then ask for another one. I'll do 70. And insert that into our array, and it just keeps going. Everything is perfect. Now we go to our outer loop. It ends because our loop was set up to only handle 2 students, and we'll exit out and be done. So the way that Justin has this 2-dimensional array is fine. I just want you to realize that the first entry in each row is the student number. After that, then we have the scores for that student. And this is a very valid way to set up a 2-dimensional array. A lot of times we'll see things like that when we're coding. But the textbook kind of shows it that our 2-dimensional array is only going to have scores. So I just wanted you to see this implementation is just a little bit different than what they're asking for in the textbook. Now, do you see how that's working? How can we make it ask us for scores for 3 students? Which loop would I need to alter? The outer loop or the inner loop?
I think the outer loop.
The outer loop, if I want 3 students. That would be right, because it's the one that's controlling how many students we're being prompted for. Every single student we get prompted for, we're going to get prompted for 2 different scores for them. So it's all working great. We're just asking for the student and then putting in their scores. So I think that works really, really well. Let me go back to our colab document. Does something to it. It's trying. There it is. All right, so that should finish us up pretty much on this one, except for this very last activity. So in the very last one, example 7.12, it's an update to that previous one. In this example, they would like you to allow the user to ask for a student, and then you would print out that student's scores. So I'd like you to base this code on that previous implementation that we all put in. How could you get this to work? Now, this Colab notebook is due tonight, so let me know if you have trouble with getting that done, but this is something I want you to think about on your own, because you're going to have to kind of use that visualizer site. So for this Colab document, this chapter 7, in the end, what we've done, because we've worked on this one for a while, like before Thanksgiving and after, and it's just kind of spread everywhere. All of the activities in here should be done that we did together in class. We did skip one somewhere in there that I said we'd already done, like names or something. But the main thing that I'll be grading when I grade this is I'll be looking at each different student activity to make sure that it's got the code in it that we did together in class. So as I go through it, I should be able to see all those things. If you're missing any as you go, that would be a video that you'd want to probably back up and watch from our Zoom video set. That's 7. Here's the one. 7.8 is the one that we did not do. So you shouldn't have anything for this one. Now, people in the other class said that they worked through, some different people had worked through this one using the textbook. They said it has some really interesting information, but that you will have to refer to the textbook where it says, then this happens, and it gives you kind of those step-by-step actions of what's going on. But I will not be looking at this one for grading. That's just totally up to you if you want to try it. Now, in our two-dimensional array, we also did not do that one, activity 9. And again, if you want to try it, that's fine. So activity 11 is kind of like the big grading thing for this Colab notebook. And don't worry, it's not a big grading thing. It's just that's the thing that I'll be looking at to see how well you interpreted some of this information that has really, really been spread out for a couple of weeks. These last things that we're looking at, like processing arrays, are pretty advanced topics. And I think that you'll get a lot of opportunity to practice with them in other classes. So if you have a good handle on it, a good understanding of it, that's fantastic. If you still have some question areas, that's good too, because you don't want to know everything before you go to those other classes, right? So that'll work out. Now I want to switch gears a little bit. I'm going to close out of this Colab notebook and leave that for you guys for on your own. And I want to take a look at our module for this week that we ignored on Monday. And that would be week 14. So on week 14, I just activated this assignment, so you hadn't been able to see it before, and it's our image glitch assignment. Today, we're going to start looking at processing data that's in sequential files, and we might have time to get into our image glitch, but I'm not going to worry about it if we don't, because if we don't, we'll just have plenty of time on Monday to get started with it. It's due December 10th, so it's still late next week before it's due. Hopefully, we'll get a chance to get to it today. Before we do, though, we've got to look at sequential files. In sequential file processing, I want to refer to another site that we haven't used before. So I posted the URL in Discord. You don't have to use that Discord link, though. It's pretty easy to find. The site that I want to find is called Runestone Academy. So with my poor memory, I always have to think, what is it, and I always the RuneScape, no, not RuneScape, and then I find it. So I think they were RuneScape people too. So Runestone Academy is just another one of the billions and billions of sites available for you to do Python self-study. It has a bunch of textbooks online. So if you found the site, Runestone Interactive, let's click up here where it says Our Library. And the library we want is way down at the bottom, How to Think Like a Computer Scientist, Interactive Edition. Now, once we click on that textbook and get past the ad, this is the URL you want to save. So this URL is URL for this textbook on Runestone Academy, and that's the one that has to do with Python. Okay, you see it? Now, again, if you want to do more practicing of Python, this site is really awesome. Students kind of don't like it. You guys are just terrible. You really like flashy sites. I mean, I know you don't like things to flash at you, but you like them to be pretty, like Code Academy, even if it doesn't have the best content. This site is ugly, right? But it has some really good content. So as you look through, this textbook was written by several programmers. It's actually, if you do a lot of research, it's one of the top most recommended Python textbooks available because it is computer people that put it together. But it's a little bit dry compared to some of the other things that you guys are used to using with all the flashy stuff. So we haven't really referred to it a lot. But I want to go down to section 11, where they talk about files, and we're going to start taking advantage of their content here. This is also the site that we're going to use for our image glitch. But if you go down to section 11, let's go into 11.1, working with data files. Now, the way this site works is they actually have the Python visualizer embedded in the site. So when they give you example code, you can run it on their site, or you can run that visualizer right here on their site. So it is pretty nice. Now, as we go through it, notice it has some text stuff, and then it has like some sample code. And at this point, that's the end for this page. I would click this next button down here to move forward in the content. And I could use this button over here to move backwards. Now, right now, we're not logged on. If you were logged on, you would be able to keep track of your progress. You know, it would turn things green as you completed them and stuff like that. So if you want to create an account, you can log into or enroll in the CIS120 course. It's always out there, and it has access to all of this stuff if you do want to keep track of your progress. So since we do have a little bit of reading here, I know we don't have everybody in the room, but it's best if we have students kind of popcorn read this, you know, or just different people read paragraphs so that everybody stays paying attention. Some teachers, it's so funny, some teachers say, you shouldn't do that because it makes people really stress about reading. And from my experience, I've found that that's true, and that stress is good because it keeps people on topic and they keep paying attention. So let's start with one of our awesome people here in the front row. Start us off reading that first paragraph.
Opening a file requires that you, as a programmer, and Python agree about the location of the file on your disk.
I think you're a page ahead.
Oh,
See, that's another good reason to read together.
so far, the data we
Yay!
have used in this book have all been either coded right into the program or have been entered by the user. In real life, data resides in files. For example, the images we work with in the image processing unit ultimately live in files on your hard drive. Web pages and word processing documents and music are other examples of data that live in files. In this short chapter, we will introduce the Python concepts necessary to use data from files in our program.
Okay, go to our next person there.
Alright. For our purposes, we will assume that our data files are text files, that is, files filled with characters. The Python programs that you write are stored as text files. We can create these files in any of a number of ways. For example, we could use a text editor to type in and save the data. We could also download the data from a website and then save it in a file, regardless of how the file is created. Python will allow us to manipulate the content.
Author Daniel, can you get that last little one for us?
In Python, we must open files before we can use them and close them when we are done with them. As you might expect, once a file is opened, it becomes a Python object, just like all other data. Table 1 shows the functions and methods that can be used to open the full file.
Awesome. So whenever we look at those test scores for our students that we were talking about in that last two-dimensional array program, we saw Justin drop that count way down. Let's do 2 students and 2 scores, because otherwise we're going to be here all day entering this data every time we test this program. Why we have to have files. Our users can't do that either. Now, a file is something that might be considered a little bit old-fashioned. A lot of our systems nowadays are going to be using databases, but they still might use text files. One thing that's important to me that I like to really pound into people's head is a file is a file is a file is a file is a file, right? They're all the same. They are not different. There is no magic file that is a Word document or a magic file that is an image. They're all just files. They just have data inside of them. It's only how the program interprets that data or writes that data out to the file that makes it do something unique. So if I'm looking at a Word document, if I open that Word document in some sort of text editor that's not Word, I'm going to see what looks to be garbage. I'm going to see control codes, like our \n control code that says to go to a new line. Word is going to use different types of control codes that are meaningful to Word. Like this control code is going to change the font. This control code is going to change, the font, the typeset size. All sorts of different control codes like that are going to be useful in Word. So the Word program is going to write those special control codes out into that file, and it's going to understand how to read them and interpret them. If I use an imaging program, that imaging program, again, is going to understand that the data it's reading from that file are different color codes or different pixels. So it's going to know how to handle it. The files themselves are all exactly the same. As far as Windows is concerned, those are just a bunch of files sitting out there on the hard drive. Windows itself, the operating system, what's it made up of? A bunch of files, right? Code files, executable files, but they're all just files. So we can read them all in our code, right? If I want to figure out what an imaging program is because I've decided that I'm going to become the ultimate meme maker, and I want my memes to be completely unidentifiable. I don't want anybody to be able to track that back to me. Well, I could write some code then to alter that image file or to overlay one image on top of another so that there wasn't Photoshop remnants in that file of it having been altered and changed and things like that. So that's why the developers have the power. So any kind of file I want, I can open it, read it, process it, and close it. But I need to use specific controls. I can't access a file if I don't know where it is, what its file name is. So you see in our open command, we have to specify what the name of the file is. What file do we want to open? And then we have to specify how we want to open it. The R in Python says, I'm just going to read this file. The W says, I'm going to update this file or write to it. So I have to be sure to open my file, telling the operating system what I'm going to do with it, and then I have to close it when I'm done. If I leave my file open, it's in an inconsistent state, and I can't be sure my updates were applied. Okay, for this section, I don't want to really read through it because it is a little bit tedious. Let's scroll down and let's look at this picture. What folder is data1.txt in? My project. Exactly. Does everybody see that? What folder is my project in? All projects. And what folder or drive is all projects in? My files. Exactly. So when we see something like that, let's look at one down here. Do they have an example? They have all sorts, but not really any of the ones that they're kind of talking about. Here we go. Open down here, it says, before the My Files folder, we also have a users folder and B. Miller. So B. Miller, our computer user, has this folder, My Files, and within My Files, he has a folder named All Projects, and within his All Projects folder, he has a folder named My Data, and within that, he has a text file named Data3. That's his complete path name. Whenever I start the beginning of a name with a slash or the drive letter, it could say like C colon or D colon there. That's an absolute path. So I'm giving the program the full and complete location of this file. So I don't care what folder you're in right now, this is the absolute path to find the data3.txt file. So the absolute path starts with a backslash and includes every folder that must be passed through to get to the file we're looking for. We have that structure going. Now, besides an absolute path, though, I could have a relative path. If my current folder, the folder I'm currently in File Explorer, is the My Project folder, I could access data1.txt just by specifying its file name, right? Because it's in the same folder as I am in. However, if I were up a little bit further than that, like my current folder was the All Projects folder, then I might have to specify, oh, go into the My Data folder, and then you can find the data2.txt file. That's still a relative path relative to where I am. So an absolute path gives every bit of information to get to a file. The relative path says, based on my current location. Let's open a command prompt and try a little bit. So I'm gonna see if I can get this to where you can see it. Let me get this out of my way. Stop it. All right, so I want to open a command prompt. So on my start menu, I'm going to type CMD, and then I just want to open that command prompt. Now, when I open it, what's my current folder? Oh, it's my Riley RE folder in the users folder of the C drive, right? So that's the folder I'm currently in right now. That's my current folder. Did yours open that same way, the C drive? Okay, because it can change. They used to map your documents as your H drive, so it would open in the H drive folder. But if I'm looking at a command prompt and I want to see all of the files and folders in my current folder, I just type dir. And the dir command, the directory command, gives me a list of all of the files and folders that I have in my current folder. I have quite a few. You probably don't have as many. I'm kind of a folder hog, file hog. But look, most of mine are directories. So does everybody have a documents directory? Let's go into it. If I type CD, I'm issuing the command, change my current directory. So for this one, I would like to change my current directory into my documents folder. Now my path, my prompt changes. My command prompt is always showing me my current folder. So it changes. Let me try to make it where you can see that whole thing. Well, I can't do that. I just made it really mad. Too many things opened. Okay, so in my documents folder, I don't have very much because my actual documents folder is on OneDrive. So I'm only seeing the stuff that's been saved to this computer. I don't see very many things, which is fine. What I wanted to show you here is that every folder has two files or two hidden files that help the operating system. The dot and the dot dot. How many of you guys have had web does? You do the dot thing when you do file names? You know why? You know why, right? Because you're saying based on the current folder. So one single dot is always current folder. So if I do the dir command without specifying what folder to do a directory list on, it does my current folder. If I do the dir command and specify the dot, it'll do the same exact thing because the dot means current folder. That's what it always means. Now, the dot dot means the parent folder, the folder right above this one. So if I were to do a directory command on that synonym dot dot, I would see my Riley RE folder list again, where I started out, because dot dot means parent folder. So those kinds of file system things are kind of behind the scenes, sort of hidden things. And I just want you to be aware of them because they'll help you a lot as you're working and trying to figure out why your program can't find a certain file or something like that. Now let me try to get back to where we were because I got way far off. So all of that is important for finding a file on your disk. The dir command is the super most important command you can know. I was reading something a couple weeks ago. It was some sort of joke. And they said if you ever want to look like you're really smart, just bring up a terminal window on your Mac. Right? I don't know why I was reading stuff about Mac. But if you've ever brought up your terminal window, it's the same as the command prompt window. And they say, that's going to impress everybody around you. Right? Now, if you could actually type a command and make it do something, then they're going to be, oh, wow. And then the dir command is super helpful. So anytime you're just in a situation where you're stuck at a command prompt, you've been following instructions and it's got you out there and you're not exactly sure what to do, the dir command, the directory command, is kind of just a way to help you get your mind around what's going on. You know that command, you can type it, you can see what files are in this folder, you can kind of look around and get your feet wet, so to say, and figure out where you are. So it'll help you. All of this matters because when I'm writing a program that's trying to read a file, I have to be able to find that file, or I have to know where I'm going to save my output file. So that's why I want to kind of veer off and show you a little bit of those DOS commands. All right, so we want to read a file. We're going to read this file here. This is called qbdata.txt is what they want us to name this file. This is an example. So let's take a look at it. In our file, we have a bunch of rows and a bunch of columns, right? Just like with our two-dimensional array. we have a bunch of data in here about quarterback. And so first of all, we have their name, this position here. Every single one in our file is QB because they're all quarterbacks. So we must have pulled this file from a file that contained other types of positions, but we don't have that data now. The next column is the team they play for, then how many completions they've had, how many attempts, total yards, total touchdowns, interceptions, their completion percent, and then their some sort of ratio, or completion ratio. So each of these different data items are available for each of these quarterbacks. That's what our text file is. They say if we wanted to open this file, we would call the open function. Let's try it. For this part, we're going to get away from our colab notebooks because our colab notebooks are going to add a whole bunch of complication to reading a text file. So the first thing I want to do is I'm going to use File Explorer here, and I'm going to go to my 120 folder where I keep all of my stuff for our class. Let me go find it. And in my 120 folder, I'm going to create a new folder. And I'm going to call this File Handling. So then everything that we do today, I'm going to put in that folder. Why? Because I want it to all be in the same folder so I don't have to do any full absolute paths. I want to be able to use relative path names for all of the things that we're going to do. Okay, so in our file handling folder, let's create this QB data file. We need to copy everything. So I'm just going to select it all. Just this data part is all we want. And I'm going to copy. In my new folder, I'm going to create a new text file. I'll just right click and say new text document. And this is going to be QB data. And then I'll paste all this data in there. So it's just a text file. I want to use Notepad because if I use any other program, I risk getting weird control codes stuck into this text file. If I open this file with Word, I've corrupted it. I risk that there will be control codes plopped in there. If I open it with any other program, I've corrupted it. I can use Notepad and I could use Notepad++. But those are my only choices really for a default text file. Now, if this file is not properly created, I could do file save as, and if I did not want it to be a text file, I could change the .txt to a different file type. But I want it to be a text file, so that's fine. Okay, so now in my file handling folder, I should have my QB data text file that I copied from this site. Now I'd like to have a Python program here. So again, I'm just going to right click and say new. I'll just call it a text document. And I'm going to call this, what do we want it to be? File testing .py. And I do not want the .txt. Now, before I go on, let me mention, if your display doesn't look like this, you need to change your view settings. I hate looking at that screen since it's gotten all messed up. How do I do that? When you're using File Explorer, you on your view, and you might need to go change this view and then come back and fix that other stuff. But on view, you must have file name extensions checked and hidden items checked. As a software developer, you should always be viewing files with those options set. When I'm looking at a data folder like this, I also should be viewing details, the details display. The details display is showing me the size of the file, other important information about it that's going to be helpful to me as a programmer, and it's letting me see the file name and the file type, right? If I'm not got my view settings right, I'm going to mess this all up. I'm going to end up with a Python program that's named filetesting.py.txt. And I'm not going to understand why it won't color code right or work right, because I was being stubborn and refused to change these settings so that I could see that file name extension. As an old lady that's taught programming for a long time, I know a lot of people are super stubborn about these settings, and they will screw themselves. Best to do it at school and not at work, right? Okay, now are we set? So in our folder, we have two files. We can see their name and their file type. We can tell that we have qbdata.txt and we have file testing or whatever name you gave your Python file .py. Everybody good? Got it? Tell me now if you don't, because it's just going to get worse. Anybody at home need help? Got it? Got it? That other class is doing all video on this. Okay, let's fix our Python program. I don't want to use Colab, so I'm going to right click and choose Edit with Idle. So now that I've got idle open, I'm like, this will be a good thing for us. It will remind us that we do like Colab. So let's put some comments in. My script here, file, testing. It's very Christmassy to go back to idle. That's one nice thing, right? Because it'll be all this red, green stuff. To test with text files. So I'm going to move this out of the way. And in our Runestone stuff, it says down at the bottom of that page, they want us to try to open and close that file. That's all. So they say we should use the syntax file ref. So we're creating a reference to an actual file. We want to open our qbdata.txt file, and we want to read it. So our open function requires two parameters, the file name and the file mode. Now let's just close it. File ref, we want to close you. And this doesn't do a lot, right? But if we've got an error, it's going to break. So let's try and run it. If it does nothing, then we're in good shape. So it started, it ended. I didn't get any error messages. So I think everything's good there. So far, so good. Everybody's okay? We're able to open it and close it. And you know, when we make it work, it just doesn't seem like it was a huge hurdle, but it really was a huge hurdle. because we've got our text file created, we're able to open it in our Python code, and we're able to close it. So now let's do some reading of it. When we want to get the data out of that file, we call that reading the file. Like when we're looking at test scores, we usually want to read things for input. Whenever we were doing our \n in our code, we were putting a new line character into our output for the console. We can do that same thing when we're looking at a file. So if I'm open my file again in Notepad, there is actually a new line character at the end of each of these rows. I can't see it because it's not printable, just like the \n doesn't print for us, but we know it's there. That's why I have to use Notepad or Notepad++ to process this text file, because I do need that new line to stay there. Another thing that's important is at the very end of the file, there's an end of file marker written. Again, another unprintable thing that we can't see, but the operating system uses to know that it's getting to the end of the file. So new line characters, other hidden codes can be in our file. Notepad is going to take care of that handily. We don't have to worry about it. So if we want to read through all of our file, we want to read every line in the file, we could use a for loop. And just like we use the for loop to read every entry in an array, we could say, hey, for loop, I want you to read every line in my file. So here's an example. Let's try it. They say we can add in this code for a line in QB file. So let's fix ours to be like this. Now, first of all, they've changed the name of the file reference to QB file. So when I close the file, I need that same file reference name, QB file now. So we can tell that's a name that we can assign. We're just saying call this file QB file while we're within this program. Now in our for loop, we can process each line of the file or each row. For a line in our QB file, we want to get some values out of there. So let's take that line and split it. And the split command is one that we used a little bit. It just says, every time you find a space, create a new entry in this output list. So it's going to split that row up into the individual columns. Let's take a look at how it splits that up by printing afterwards. First, we're going to print QB. Then, looking at our values list that we just created, we're going to print out index location 0 of our values. And if we look at our file, that should be like their name. Then we want to print out the index location 1 thing in our files. Then the words had a rating of. Then finally, the 10th thing, values with an index level of 10. So if we look at our file, item 0 should be their first name. Index item 1 should be their last name. Then what about index item 10? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be this very last number that we're getting printed out for each of them. So that split command said every time you find a space it's a different item in our list, our values list. Okay, let's run it. Now, in this one, we should see output for each of those quarterbacks. There's a bunch. So we've read through our file, and we've got all of our quarterbacks output here, and then we're good. So can you imagine having to type all that in? Already we're seeing how this text file can be huge savings for us. If we'd had to type all those entries in, we'd be here all day trying to get it. Let me put that code back for you. Can you see it? How's everybody doing? Okay at home?
Mine doesn't work.
What's it do?
It just doesn't sound.
Here, let me quit sharing so you can share. Show us what it's doing. Does it give you any sort of error?
No,
Oh, I think you're missing your closing parenthesis on your print statement. Those square brackets will get you every time. See if that's it.
there we go.
Yeah, yay.
Thank you.
Sure. Anybody else? Anything looking weird?
I'm getting an error, but I think I just missed what he had in the QB file.
Can you show us?
Sure.
Let's make sure that's what's going on because we'll get you that file. Okay, so do you not have it?
Yeah, I think I missed it when you had it.
Oh, let's get it for you.
Okay.
So let's look at your folder.
Oh, sorry.
That's all right. Just stay there. There will be other people that are in the same shape probably. So let's look at your folder. Oh, and you do have it. So double click it to open it. Oh, let's delete all that.
Delete all of it?
Yeah, we just want those data rows in there. I'm not sure what you've got in there. It looks like you got their whole website.
That's probably what I did.
So Control A and delete. That makes sense. Do a Control A to select everything and just delete. And then go back and just select those data rows there behind us. Make sure you just have the selection going on inside that gray box, and that should limit it.
That explains it.
There was lots of stuff in there, huh? I'm glad we looked at it because I'm sure other people have the same thing, because when you're copying and pasting from the web, sometimes that happens. Okay, now let's see if your program will work. Oh, yep. Did you see that annotation where it says file ref equal? Make that say QB data. Yeah. Actually, no, for this one, we changed it from file ref to QB data.
So QB data is right?
Uh-huh.
Okay.
File ref is what's wrong.
Okay.
Change that to say QB data instead.
Oh, gotcha.
See, now there were other people I'm sure that had that problem. So in the first example, they called it file ref, and then the second one, they changed it. Now let's see what it does.
There we go.
Woohoo! Okay, anybody else? Trouble? Let's get them fixed. So nice when it all works. Okay, so we read our file, we split up each row into its individual columns. Those individual columns went into this values array, and then we selected which of those we wanted to print. So we're able to handle this thing without any issues at all. Let's look at some other ways we could do it. Now, we did, in our code, we said the for loop is going to handle reading our file, right? So this for loop is just starting out with the first row in our file, second row in our file, and it's just going to keep going. When it gets to the end of the file, it will be done with the loop. So that's a really nice way to handle it. We have some other things that we can do if we want to, though. We could also issue a read line command ourselves. And if we did that, we would just get one individual line. So let's try it. Let's put that in our code here. I'm going to put it above what we already have. And we'll see if we can mess with our file a little bit in different ways. So this time, let's call our file in file. We're going to open it. As read only. And then we're going to use a variable named a-line, and we're going to set it equal to whatever Python can find when it reads a line in our input file. Let's print out that A line. And then let's close our in file. Oops, I did it backwards. We have to say in file dot close. And I'm going to use an input statement to say press any key to continue right in the middle of my program here, so that I can make sure I'm reading just that one line. And then when I press enter, it should print out all of the other lines in the file. Let me run that. Okay, so, silly thing. The first thing that happens is it outputs that first line in the file for me from my read line statement, and then my input statement took over and is sitting here waiting, saying press any key to continue. Now when I press a key, the rest of my code will run, and it'll read the whole rest of the file and print out all that quarterback data. Okay? Bring that back up for you. So in this example then, we opened our file once and read one line from it and then closed our file. Then we open our file again and read all the lines from it, and then we close our file. So notice how we have different Python functions we can use to access our file in different ways. So in that example, we did one read line. We also have the option of doing read lines as a function. If we did read lines as a function, we'd be reading in all of the lines in the file into an array, an internal array called line list. In this example, they print out just the length of that array so that you can see all 34 of those quarterbacks would be loaded into that list. Now, the next thing that they do is really interesting. They print out line 0 through 4, or index entry 0 through 4 of that line list file. Let's do those two. I'll put these in our program. I want to go ahead and put that in our top half. Line list equals in file dot read lines. Then we want to print out the length of our line list array. How many lines did we read? And then we want to print out our entries 0 through 4. And then finally, we'll close our file and pop up that message, press any key to continue. So let's try it. So first, my read line command gets the one line. My read lines gets the rest of them. Notice we only got 33. We didn't get 34 because we've already read this first line. The read lines command didn't back up and give us that one again. It started where we left off and continued on. So we got the remaining lines out of our file. So when we printed out entry 0 through whatever, we got Josh here, Michael, Matt, and Philip. So notice how our file access is dependent on our current location in the file, just the same as finding a file is dependent on our current location in the file system. That we can't read through that file unless we've already got access to it. Okay. Now, the next thing, oops, are you still looking at it? Let me put it back. I heard that one. Sometimes with our square brackets and colons and other things, it's just like learning how to use the controller of a new game or something where you just have to get used to it. So we could read the whole file using a for each loop. That is obviously the easiest, right? We can use read an individual line out of the file with a read line function. We can read all of the lines out of the file with our read lines function. What else do they have there that they're showing us? We could use the infile.read, and that would tell us how many total characters there were in that file. And then we could print out like 0 through 256 characters. That's what that last thing is. We're not going to put that into our program because that wouldn't be something that we would do very often. It would be kind of an unusual thing, but I want you to be aware that it is a possibility. So the last thing we might need to do is to write a file for output. What if we want to update this QB data file and we want a new version of the file that's been updated? We want to do some outputting. We want to do some writing. So let's practice that. I'm going to go forward and we'll write our file. So for this one, I'm going to close out of my Python file that I've been working on and create a new one. I like making you do things a little bit different of a way to expand your horizons. So go back to File Explorer, to the folder we're working in. And again, right click and choose New, or you can do, Alt F or whatever to create a new file. And we want to say New Text Document. And this is going to be file writing.py. Make sure you get rid of the .txt. Windows is going to gripe at you about changing that file extension, and you're going to say, yes, I'm sure. Quit telling me what to do. All right. Okay, if you've got your Python file created, let's edit it with idle. And in idle, we'll start with our comments. Write an output file. So I'll just say our purpose is to write an updated file as output. And what they want from us here is, first of all, we're going to set our QB data file up as our input file. They want us to call it in file. So we'll say our in file variable is actually a file reference. We want you to open our qbdata.txt file for read. So we're not going to try to update our actual file. We're going to use it as input and output a new one. So we're not going to do like an in-place update of that one. We want that old original one to stay the way it is. So let's read in a line. And then start a while loop. While our align character variable is valid, let's repeat this loop. So while you can read a line, repeat my loop. And my loop body, I'm going to start out creating a variable named items. And this is going to be all of the different columns in that row that we read from our file. So split it up into columns, put those columns into this items array. Now I'm going to create a new data line, what I want my new row to look like in my output file. I would like it to just have the last name plus a comma plus the first name. So I'm just going to rearrange that first and last name. So it's last name, comma, first name instead of first name, last name. I want to print that out so that we can see it, make sure it looks good. And then we're going to read a new line. Finally, after we're all done with our while loop, we're going to close our input file. So in this example, we're not actually creating an output file yet. We're just preparing to. So we are saying that our output file is going to contain rows that just have the last name, comma, first name. So we're just researching, kind of doing our troubleshooting here to make sure this works. So let's run it. And yep, I'm getting all of my quarterbacks here. Last name, first name. And now I can change this thing to make it actually write an output file. Right now, I only have an input file. I need to add an output file. Out file. Let's name our output file qbnames.txt because it's just going to have their names in it. Now, when I'm creating a file for output, my file access flag has different settings. I'm going to use the W flag to say I'm going to write this output file. Now, if the file doesn't exist, it will be created. If it does exist, it will be reinitialized. So we're not going to be adding to it. We're just going to be overwriting it every time we run. Now, in our output file, here we've opened it, but we need to write things to it. So let's replace our print statement with the code necessary to write to our output file. We have to specify what file we're referring to, our out file, and we say, I would like to write. Well, what would you like to write to this output file? A data line. I've already got my data line formatted the way I want. I know it is because I just printed them all out. They all looked good. So instead of printing them, I'm going to write them now to my output file. But I do need to add my new line character after each one, at the end of each one. And if you notice again, this code switches back and forth between single quotes and double quotes, and that's okay. There isn't any meaning. Now I need one more thing. I'm going to run it without adding that one more thing so you can see how important that one more thing is. When we run this, we should end up with a file qbnames in our new folder that we're working with. So I'm going to put this folder over here so that you can see it, and I'm going to run this program. It ran. Do we have our QB names? Yep. My file's there. Does it have all the names in it? Let's check. Oh, it's empty. So it created the file, but it didn't do it right because I did not close it. Because I did not close it, it left that file in an inconsistent state and there is no actual data in it. So let's add that out file dot close. Now when we run it, not only will it create the file, it should actually put some stuff in it. So now I'm going to check my file, and sure enough, now my names are saved. So that close statement is really important. Everybody worked? Got good data out? Yay? Everything okay? Do I need to even copy any of my code? You're so awesome. All right, so the only other thing we have as an option for an output file is that I might not want to rewrite the file every time. So I could change this W, this access mode, to a different access mode. Let's see what we can find. I'm going to say Python write a file. I'll try this W3 schools one. It looks good. Here it is, right there, very first thing. It says A appends, so that will add to the end of the file, whereas the W that we used will overwrite the file each time we run it. So you could use either way, either thing you want. Questions? I think you guys wanted to start glitching images. Yay. Let's close all this. Now for our file access, as I'm developing your final, I feel like it would be good to have one objective, have you write something to an output file. So do keep this code, but it's not something we've done a lot of practice with, so it wouldn't be a big part of your final by any means. And as you can tell, your final is under development. All right, so let's look at imaging. We have time. 20 minutes. Oh my gosh, we can do it. So I want to go back to the table of contents on this thing. So I'm going to click on this Think CS Python, and go back to the table of contents. And what we're looking for, I have to remember, they have it like hidden somewhere, and I think I may have passed it. If you see it, does someone see it? It says something about working with images. Yeah, where is that? Ah, thank you. That's the one I'm looking for. Okay, so we want to go up a little bit though. Let's start at 8.11. Two-dimensional stuff. And again, when we're working with two-dimensional items, often we're just going to put things in a file, and we're going to handle things in a much more reasonable way, less complicated way than using a two-dimensional array. But when we're working with an image, it's such a logical way for us to work with things. So they want us to think about an image being a collection of pixels. So if I'm looking at my TV and my TV is a 4K, then I have what, 4,000, 4,000 and some pixels across, right? And I can have, I don't remember what the horizontal resolution is with 4K. I think it's pretty much all the same, 1920 or something for all of the high def stuff. So like if you buy a TV that's 720p, you have 720 pixels, we're getting used to that sort of thing. We do that. Well, these images that we're looking at, whether they were done in Photoshop or I took them with the camera or my phone or whatever, an image is just a bunch of pixels, just a bunch of pixel locations. So here's my row 0, column 0, row 0, column 1, etc. My two-dimensional array, that's my image. They're focused on that pink pixel down there. That's at row R, column C. And they're saying, look, you could focus in on this individual pixel if you wanted to. That would be nice. So let's back off a little bit, talking about that two-dimensional array, and back up to think about colors. If you're in the web dev course, you probably have done a lot of work with color codes. But if you're not, if you haven't taken that course yet, you maybe haven't. So every color code that we use on the system is made up of red, green, and blue. So any pixel that we look at has those 3 colors. And we have some other things that can be involved in that, but that's our basic color triad, is the red, green, and blue. So looking at this table they have here, they say that for something to look completely red, our red pixel or value is going to be 255. Our green and blue values will be 0. So a color code, color value can be anywhere in the range 0 to 255. For each pixel, I can have these 3 color codes anywhere in that range 0 to 255. So in order to manipulate an image, we need to be able to access individual pixels. And then we need to be able to maybe see what the actual color code is for that pixel right now and maybe update it. So we're going to be using this module called image that someone has created that we're going to go grab. And in that image module, we can use specific functions like get red, get green, and get blue for a specific pixel. We can also say get pixel or set pixel. So we can get the current pixel value and set the pixel value to something different. So here's a little bit of example. Each pixel is going to be comprised of its red, green, and blue color code value. And then if we get red, we would just get the red component of that. If we wanted to change the red component, we could say pixel.setRed and then whatever value we wanted. So let's look at this example here. In this example, they create a pixel with 45 units of red, 76 of green, and 200 of blue. Then they print the current amount and do some other stuff with it. So let's run this here in the Runestone Academy. And then we see the output down here. The red is 45, the green is 66, the blue, I don't know, is 76, and then I think they changed the green. So we see this code here. They just want us to see that this code is pretty standard. We use the variable p to be a pixel. Then for our p variable, we can get the red component of it or set the red component of it. We can get the green component, get the blue, all those different things. Okay, check your understanding. If you have a pixel whose RGB value is 5000, what color will this pixel appear to be? Light red. Yeah, it's bad. Dark red. Yeah. I would have gone light too. So that's good for us to see. The smaller the number, the darker the color. That's an interesting one, huh? We can mess with it a little bit. Okay, so we're going to take a picture that's an image and use that as an image object. Then we'll be able to look at all of the pixels in that image object and kind of update them. Here's one they already have for us. So here's this picture of this bell at this Luther College. They say this image is stored in a file called luther.jpg. Line 2 opens the file as an image object. Notice how it doesn't do it is an input file like we were doing earlier. It's using this special code to create an image object. And then it prints out some information about this image, the width of it, the height of it, and then it gets a pixel. Let's run this. So down at the bottom, you can see the width of this image is 400 pixels. The height of this image is 244. At the pixel at location 4555, we have a pixel that's colored at 165, 161, 158. Okay, great info for us. We can see how that code lets us gather that information. So looking at that code, select the answer that is closest to the RGB values of the pixel at row 100, column 30. What do you think? Could we just change it up here? 100, 30, and run it. Oh, that looks like an actual answer. Let's see if it's wrong. Oh, it says, hey, wait, those are the values for the pixel at row 30, column 100. We actually want it reversed. So our first number is column and our second number is row. So it's not exactly what we would expect. So now let's try it. And now we should get the answer they're looking for. Cool. So that was a good way for them to make us realize that that was kind of counterintuitive, right? Not what we would expect. Now, as we go through looking at the image, there's lots of things that we could do. What are they wanting to do here? We can have some nested for loops so that we look at each column of every row. We know about nested for loops. They're trying to explain those things in the same thing. So that's good. You could use this if you wanted to for a little bit more practice. But now I want to actually do something with this image. Here we're finally doing something with it. So we have our Luther JPEG. We're going to get its width and height and open a window of that size. Then in that window, we're going to draw this Luther image. And then we're going to start going through all of the rows and columns in that image. And we're going to update the red, green, and blue values for each of those pixels. Let's run it and see what we end up with. So here's our Luther College before image. And notice how, as we are running, we're processing each row and each column in each row. And it's kind of slow pokey since it's updating each pixel for us to see as it runs, but it gives us a good visual of what's going on. So what did that do? I call it a negative image. So we basically said we want kind of the reverse of each pixel's color. So if the red is 47, we're going to make it 255 minus that 47. So we're taking out the actual color, so sort of a negative image. So this calculation here, 255 minus the current setting, will give us a negative image. That's kind of cool. If we look at those glitched images that we were looking at the other day, we can probably see some right here. This one has a lot of negativing going on it, where they did that sort of process to it. I don't see too many others. I don't think that have that, just that negativing thing. So that's an interesting thing that we can do. Now, what if we want to do a grayscale? They say, oh, you can do all sorts of other things. You can change it to a grayscale by averaging the red, green, and blue intensities, and then using that value for all of the intensities. From the grayscale, you could create a black and white image by setting a threshold and selecting to either insert a white pixel or a black pixel into an empty image. So all sorts of different things that we could do to glitch up our image. So let's see if we could do this ourselves outside of this tool. So far, we've got a cool thing going with this Luther College picture, but it doesn't help us much with getting something to happen to our own picture. Okay, so everybody with me? We're going to get started here on this. And again, there's a video out there, and I'll save this video, but it's so much better if we can do it together and get it all going together. So I'm back to my folder where I keep all my 120 stuff, and I want to create another new folder. I created this file handling one, and we put all of our file handling stuff in there. That's great. Let's create a new one now for image processing. And I'm going to call it image processing, because if I call it image, I'm going to end up with 75 things in here called image, and I'm not going to know which is which. So I'm going to be a little bit more specific than that. So in my imaging processing folder, the first thing that I want to do is find this image.py code that they're referring to. And they've got it in here somewhere hiding. And I'm gonna have to look for it. I apologize, but they move it around a little bit every single semester. And the ads are new. There it is. So find section 8.12. It talks about image processing on your own. And in this note, this is why I want to do this together, not because you guys aren't capable, but because it's kind of hard to find all the pieces. In this note, we want this link here that says Python package index page. Let's click on that. That's not what I want. Hang on. Oh, it's this link right up here that says the GitHub page. They got the pillow link all really nice, but the one we actually need, not so much. So up here at the very top, 8.12, this link that says the GitHub page, open that. Now, when you get to the GitHub page, we want to find image.py. Here it is. And somebody's added Max's error checks. Cool. Mouse over to where the link is on image.py and click on it so that we can see the code. The best thing to do at this point then is to click on this raw button so that we're just seeing this raw Python code. And I just want to copy it all. So Control A, Control C, and now go back to your folder. And we're going to create a new text document named cimage.py. Open that file and paste this code. Oops, sorry. Right click and edit in idle. We can never just double click to open it when we're working with idle too much. Now I just want all that code pasted in there, and then I'm going to close it. Now this is their code, not our code. This is a file now that we're going to use in an import statement. We're going to say import this CImage program into ours so that we can use it. So we don't really want to change it. We don't want to look at that code too much. It's not something that we need to worry about, but we do need to have it in our folder. Okay, did everybody get it okay? Let's help anybody if they need help with it. So GitHub is just a place for programmers to store code and makes it easy for us to share it with each other. The next thing we need to do is find an image file for us to finagle. So let's go find one really fast, and it needs to be a GIF. GIF. Let's see, what do I want? I don't know. There's one out there. I would like a picture that has some different colors in it. You know, something that would be easy to tell that I did that reverse image to, but I don't want an image that's super huge. So try to find something that's like small, cute, has enough colors that you can really tell that it's been affected. How about a Muppet? I'll do Kermit is a little green, but I'll try him. Now, because I want GIFs, I'll put that in. What do I want? Oh, Kermit, come on, have some more colors. I could do this one. I'll do this one. There he is with a bunch of colored guys. All right, so how should I save this? Well, I'll tell you, the easiest way for me is I'm just going to right click and save image as. And then I'm going to make sure that I'm saving it to the same folder. As I do that, I'm going to make sure that my type is GIF, because I could really easily, depending on what I try to copy here online, I could end up with something that goes to .html or something that's not really going to let me save that GIF image. So do make sure that it's going to save that GIF image. Go to the correct location for your folder. And in your image processing folder, save it. I'm going to make mine a little bit shorter of a name, and I'm just going to call it Kermit. Now, if I had some Photoshop time, I could open that image and resize it and make it smaller so that I could run it through this image handling program a lot faster, a lot easier. So that is an option. And that would be something that I could try. Okay, find an image that you like and get it saved. And then I'm going to go find our Luther code. There we go. So let's create one last file. We're out of time. We'll just create this file real quick. I'm going to say new text document, image glitch.py. And then I'm going to edit that in idle. I'm going to get this code copied, and then I'll let you copy that. Now let me run this real quick. Let's make sure it works before you are trying to get this in yours. They say put image.draw inside your nested loop. Okay, let's try it. So in this one, I think it's working. We're just not seeing the output. So I see that here's my image window. It's right in my Kermit file. And it's going through these for loops, it's got to be, but it's just not redrawing my window to give me the output that I want to see. So we're super, super close. It says, put image.draw when inside your nested loop. So it should be showing it to me. My image could be too huge. Is anybody seeing any output?
Mine won't even run.
It won't run? Okay, let's put him to sleep. We'll fight with him Monday. I was hoping that you guys could have an opportunity to experiment with him over the weekend. And I will make sure that you can see the video that the other class has access to so that you can do that if you want to. It would just be at the very end of the video because we're at the very end of the process. So I'm going to save all this, but I know you guys need to get going. So in Canvas, it will just be set up on our lesson 14 page. I'll show you here if it will copy it for us. This one. In your week 14, this lecture file handling and image glitch is a video, and it's very long. It's a whole class, so you do want to go to the very end. But if you guys want to keep battling it, I will find the answer for you. Let me get this open. And if you need to get out of here, you just go. Don't you worry about it. But if you want to fight with it, we'll fix it. Let me find an old one. Uh-huh.
I had a quick question about
Sure.
chapter 7.
What's that?
We don't have to do student activity 6, correct?
What does it say?
It's the stringing arrays together.
No, you don't have to.
Okay. And then the other ones were optional other than.
Okay, I've got one here. You guys hang on. I just don't think mine. We'll fight with it Monday. Everybody's done fighting this battle. I never give up.
If you try and open the GIF, it doesn't play. So it's a static image. So that's probably why it doesn't.
Why it's not doing it? Well, I've got these others. Let me try a different image. Is yours doing anything when you run it?
Mine just says no module named image.
Oh, okay. Change your import to be like this. Import C image. And see if that, because we named it C image.
I've got a much longer error. Bad image type JPEG without PIL
Right, it has to be a GIF.
Was.
And it's so weird because like sometimes they're saved as a GIF on the internet, but they're not really internally. And it just makes it to where we start finding out some of those things that we didn't want to know. Oh, I see. I'm missing code. Duh. Start getting it in a rush. And I didn't get the rest of the code. Here it is. See ya. Now it's working. Everybody's gone. I just didn't get the last 3 lines of code. I hate when I do stuff like that. Oh well.
Okay, mine worked.
Did you get it?
Yeah.
Sorry, we were so close. Yes. Is it there? Get that done. Get it? All right. Uh-huh. Uh-huh. So let's go look at it.
Can you do this with just a plain image
Right,
as well?
so when I gave you that message October 8th, and look when you turned it back in, that's too long. That's 2 months. I don't care when you did it. I care when you gave it to me. You were supposed to give it to me 2 weeks before that because it took me a week or two to see it was missing. In this message, I sent you October 8th. Would that be an acceptable amount of time for me to make you wait to reply to a message? I don't care if you saw it or not, right? Is that matter to me? You should have seen it because this is something that popped up at Canvas, showed you, told you in Canvas you had a new grade, told you in Canvas you had a new comment from your instructor, told you all sorts of different things. You got lots of messages about that, and you went through all of them and ignored them and didn't go back and give me that updated file. You waited 2 months. Right, you missed it. Exactly. But yeah, you did it, but you didn't turn it in time. If you were at work and your boss sent you an email and said, this is wrong, I need you to fix it, and you waited 2 months, do you think you would still have that job because you missed that message? What if your commander sent you an email and you missed it? Would he care that you missed the message? Or would you be in trouble anyways?
Oh, I'm being trouble.
Yes, yes.
There's been a comment, so I can't.
No, I mean, I don't think that you're understanding. I really don't. I think that you're still thinking that you should get credit for something just because you did it. But it doesn't matter if you did it, if you didn't turn it in, right? I mean, you could do every single assignment under the sun, but if you never give them to me, I can't give you points for it. And if I give you a message on October 8th and say, I can't read this file, I can't grade it, I would expect that to be responded to quickly, not 2 months later.
Yeah, I actually respond to your message. I missed that, but I respond to your messages as soon as you actually missed that one.
Right, and that's understandable,
the
it's just a goner.
The grade being updated for well, if it's just something that was updated quick, I would have known something is missing here. It's when everything got updated, that's when I said, well, I'm missing this, I'm missing that. So it wasn't only that one. Also, this one, I did this one. I don't know how that happened, but when everything was updated, then I started seeing zeros, and I'm like, no, I did that stuff. I just.
Well, you should have an email for that one then. So let's look through your emails. It should be in Outlook, not in Canvas. So go to your My OTC. So we should be able to find it. Let's see, what would be a good thing to search for? Review questions or something like that. That day won't be good because I would, it's not very attached to Canvas. It should have the name of the assignment though. Yeah. Like maybe just week 10. Search for that. So that's the notebook, so it's different, not the same assignment. That's for some other class. So let's try to find one of the other ones. It's the same kind of assignment that you did. Go back to your grades. And then let's do week 9. Yeah, because that was the same type of assignment. Put week 09 without a space. So that's your Python notebook again. Lots of them looks as bad as mine. I didn't know you guys were getting that many. Dang, no wonder you can't find.
There's so many things.
I thought it was just me.
So I go on there, there's so many on there.
Goodness, I did not realize you guys got so many.
Sometimes I maybe like I deleted something I'm supposed to read.
You are doing so good. You need to not be so hard on yourself. I'm like, this one assignment is not going to kill you. I just don't see anything. It's supposed to be sending emails. I'd really
Yeah,
like to
or-
find one. But obviously, you're getting so many emails, you're not
Well,
even gonna see it
When I'm used to
anyway.
doing it, when I'm done with it, it shows that, okay, you're done with it, it shows the score, then I click on OK. And I feel like it's done.
Yes,
I don't know.
that one is just weird. Let me show you what I see from my end, and you can see. What I'm seeing. I'm sorry, but I feel better seeing you guys get overwhelmed by that many emails. Makes me feel better. Isn't that awful? I'm gonna end this thing.
That's not the only email I have to do.